Hello everyone, my name is Darren. I'll be showcasing a peak shaving mechanism I have developed to reduce monthly electricity expenses. The peak shaving mechanism uses PV forecast and battery storage system (BSS) to shave off critical peak demands. As you may know, electricity bills are made up of consumption and demand charges, with the electricity demands usually contributing to high monthly expenses. This is where this mechanism will play a role in overcoming this problem. Peak shaving is defined as the shaving of peak demands of industrial and commercial power consumers to lower down the demand charges of the electricity bill. Here is the model created using MATLAB Simulink. The model features a load profile, the PV forecast, the BSS controlled by an algorithm built with state flow, energy calculator, and pricing calculator. The demand limit to trigger the peak shaving mechanism can be easily adjusted here. And here is the algorithm controlling the overall BSS. The various conditions set here will control the action of the BSS. Here is one of the simulated results produced from this mechanism. As you can see, we have adjusted a demand limit for the BSS to peak shave with the aid of PV forecast. Whenever the demand exceeds the limit set, the BSS and the PV system will shave off the peaks if there is sufficient energy in the BSS. During off peaks, the BSS will be fully charged by the PV system, thus storing the unused energy produced by the PV system. The project will leave positive impacts on the environmental, economic, and social aspects. For environmental, this project uses green energy to meet energy demands, reducing the carbon emissions from fuel-based power plants. Social-wise, the world is leading towards green technologies to preserve Mother Nature and reduce pollution done to Mother Earth. This mechanism will help lead us towards this path. In terms of economics, allocations of funds can be redirected from finding fuel sources to providing the infrastructure in implementing peak shaving technologies. This alone will cut down the fuel expenses from constantly keeping generators running at high capacity. The PV system provides free energy from the sunlight to charge the BSS, and in turn, the BSS will provide the necessary energy during the times of needs. As of right now, an adaptive control peak shaving mechanism is non-existent. What is built here lays the foundation to solve this problem. With the presence of PV forecast and load forecast, the mechanism can be adaptive to selectively peak shave critical peak demands. The demand limit can be set in the form of quantized load forecast, with the PV forecast estimating the energy produced by the PV system to create this adaptive control. The BSS will form a different charging discharging schedule daily based on its available energy stored and the potential peak demands. This gives the BSS the ability to selectively peak shave whichever peaks that contributes to the highest expense. This mechanism is geared towards medium to high voltage buildings. Implementing this mechanism will help reduce the monthly expenses by more than 50%, as indicated here. The savings can be further increased if the size of the BSS and the adaptiveness of the peak shaving mechanism is further optimized. This mechanism can not only be applied in peak shaving, but also as an energy storage bank. As mentioned previously, energy produced by the PV system that were left unused can be stored in the BSS. This allows the BSS to act as an energy storage for not just medium to high voltage buildings, but to residential buildings as well. In turn, this helps reduce the over reliance of the power supply from the grid. And that is all from me. Thank you very much.